Welcome to this clinic on what you can do with a 3D printer in model railroading. So, what are we going to cover today? How about things like how I came to decide that I would invest in my own 3D printer, what it is going to cost, the most important factor in buying a 3D printer, where to go for designs you can print, things I learned about how to keep my printer and myself happy, and some design secrets for things I created myself. Before we go too far, here is my 3D printer, an Ender 3 Pro, which I bought from Micro Center in July 2020. And here are some of the objects I have printed successfully. Some I obtained from libraries, and some I designed myself. And here are some of the objects that were not so successful. 3D printing can be frustrating. You can take as many notes as you like, but be advised there is a handout with what I consider to be the main points at my website at http://daacam.github.io. Information on other clinics I have taught can be found there as well. But today, I would like to share my observation that using a 3D printer is kind of like stages of love. There are several stages: curiosity, commitment, learning to love, raising a family, sharing secrets, and mastery of relationships. Like love, it will be expensive, complex, but can be highly rewarding if you are willing to invest and learn. I know you are already curious about 3D printing and model railroading because here you are, watching a webinar on the topic. You've probably watched several other YouTube videos as well, maybe browsed Amazon for printers, or have some magazine articles hidden away. It's time you have a conversation with Uncle Dave about the facts of life of 3D printing and model railroading. So sit down and listen. If you think that 3D printing is as simple as it appears in videos and magazines, you are mistaken and will be frustrated. If you think 3D printing is quick, you are as mistaken as trying to time paint drying with a stopwatch. If you think that 3D printing will save you money, you are mistaken and will waste money. But if you think 3D printing will make your railroad more fascinating and unique, and are willing to invest and grow with it, maybe you and 3D printing might have a future together. Like DCC, 3D printing is a sub-hobby all by itself. So, how does 3D printing work? To make something with a 3D printer, you need to have a model and either use a service bureau or have slicer software and access to a 3D printer. A model is a collection of three-dimensional objects, such as cubes and cylinders, which together represent a shape you wish to create. Models can be created in computer-aided design software, and entry-level CAD software is often free. Or models can be downloaded from massive online libraries of models. Models often exist in the STL file format for stereolithography. Service bureaus are companies who have internet sites where you upload your STL models and they will print them for you for a somewhat reasonable fee and a large elapsed time. Otherwise, if you have access to a 3D printer, you can feed your models into a slicer, which will convert your model into a multitude of instructions for where to deposit a series of layers of filament with your printer. These instructions are called G-code. If all goes well, after 10 minutes to 24 hours, you may have created a trash can or the parts to construct an HO building. For my first project, I decided I wanted to create walls and floors for a 3-story building, into which I would add LEDs for random lighting. I downloaded Tinkercad design software, measured the internal dimensions of my Woodland Scenics building, and in about 5 hours I had learned enough to have a model I liked. I also learned that building size models can take between 6 to 24 hours to print. So staying in a library waiting for something to print was not going to happen, even if I could find a library which had a 3D printer, a rare beast in the St. Louis metro area. So I uploaded my model to the MakeXYZ.com website, and after several iterations it worked. But the model was big and expensive to print. Each iteration cost about $40 and 2 weeks of elapsed time from submission to delivery. Should I really consider buying my own printer? What is it going to cost? You can spend anywhere from $140 to several thousands of dollars on the printer itself. I was willing to spend $300 for my first printer, and for that I bought a machine that could print objects 220 mm by 220 mm in the X and Y dimension and 250 mm in height. It has a heated bed, aka a build platform, which makes it easier to separate the printed object from the platform. It has one extrusion system, which means it can print in only one color at a time. It can print using PLA, polylactic acid filament, a plant-based and environmentally friendly product which is readily available in about 3 dozen colors. PLA is generally available for about $25 per kilogram roll, and a truck or other HO feature might weigh 25 grams, making the object cost less than $1 in filament. Rolls smaller than a kilogram are also available. But if you want to print in colors other than white, and you don't like to paint them, you will be buying multiple rolls of filament. Yes, you can sometimes buy filament in multi-packs with multiple colors, but sometimes the quality is not as good, with the loops of filament on the rolls sticking to each other and not feeding properly into the extruder. So do the math. Good filament in multiple colors can run several hundreds of dollars. Designing your own models is not for sissies, but you don't necessarily have to design them yourself. You can visit a library, search for an object of interest, and download as many as you like for printing anywhere you like. Library objects are like the women I dated in high school and college. There are millions of them. And instead of checking them out, you can download them and they are yours forever, with many of them being free. I visited Thingiverse.com and did a search using the keyword dumpster, and dozens of images popped to my screen, most of them free. When I clicked on one, a download button appeared, and when I clicked on the button, Thingiverse would send them to the download folder of my PC in the form of a zip folder. Inside the zip folder was a files folder containing one or more STL files I could scale or print. Sometimes there is only a single file in the files folder, which I would copy and paste into a folder on my hard drive. But other times the zip file contains multiple files with separate parts in separate files, in which case I would create a subfolder to store all of these related files. But like potato chips, it's hard to stop at one, so I often ended up downloading several different models, deciding later which one I wanted to actually print. Thingiverse is by no means the only 3D library. There is also 3dwarehouse.sketchup.com, which has millions of objects of its own, some of them free. Like Tinkercad, SketchUp is another piece of design software, and the 2017 version is free. 3D Warehouse images are often stored in SketchUp's proprietary file format, which means they can be modified and eventually can be exported into STL files for printing. but I have been less than totally successful with printing objects from the 3D Warehouse library for reasons I have yet to understand. Tinkercad has its own library of designs. The Gallery tab on the Tinkercad dashboard allows you to enter keywords and retrieve objects from its library. The libraries keep on a-coming. TurboSquid is another one I like, although many of their objects come with a fee. Libraries and service bureaus sound like a fantastic idea, but appearances can be deceiving. When downsized to HO scale, many of the objects can lose integrity. When I tried to print some dumpsters, the walls became too thin to use. When I tried to print motorcycles, the wheel spokes and handlebars melted into mush, and the turnaround time it took for a model to be fabricated and delivered to my door was more than I could tolerate. So, just like some of the girls that I dated, the overall experience turned out to be something other than I thought it might be. But the experience was pleasant enough that I decided to buy a 3D printer. I was ready for commitment. Commitment. But where to begin? Amazon, of course. A search for 3D printers uncovered 209 of them, from $139.99 to over $15,000. I had already decided I was willing to spend up to $300, but I wanted a rating of at least 4 stars. I saw that there were close to 70 options available under $300. I had a starting point. I fell in love with the unit from Monoprice, their Cadet model. Its videos on YouTube suggested that it was simple enough for children, and their reviewers seemed to like it well enough. It advertised a self-leveling bed, which seemed attractive for a newbie like me. Its build plate was limited to 100 millimeters on a side, kind of small, but as a first-timer I was willing to overlook that limitation. I ordered one, and it arrived in 2 days, dead on arrival. Several hours in chat with their technical support, and the determination was that I should send it back to Amazon for replacement. The replacement arrived in 2 days, and it worked for a week, then again failed. No amount of thoughts, prayers, or online chats could bring it back to life. So it was again returned, this time for a refund. That leads us to the most important factor in buying a 3D printer. Make sure you have 30 days to return it for a full refund. I was sure glad Amazon had a 30-day satisfaction guarantee, because I learned not all commitments are going to last. It was probably a blessing in disguise. That Monoprice printer was probably too small for an HO modeler. When you buy a 3D printer, make sure it is large enough to create a 3-story building in your scale, or whatever you think you might ever want to print. 200 millimeters cubic has worked well for my HO models. Sadder but wiser, I returned to Amazon, and this time noticed that many of the printers in my price range looked similar, but were just offered from different resellers. I learned that the underlying model was an Ender 3 from Creality. It was offered as a base Ender 3 model and also an upgraded Ender 3 Pro. The YouTube videos seemed supportive, so I ordered and received an Ender 3 Pro for $250. But before unpacking, I received an email from Micro Center offering the same model for $200. So back my unit went to Amazon, and off I went to Micro Center and bought the unit I am using now. Turns out that Creality was about to release version 2 of the Ender 3 with even more features than my Pro version, but for about $60 more. Most of the V2 features can be purchased for the Pro as aftermarket items, and I was unwilling to wait. I bought an Ender 3 Pro. If I had to do it over again, I would buy the V2, again from Micro Center. But the time between when I purchased the unit and the V2 was available on the street, I got about 4 weeks of good experience and am satisfied with my purchase. Now it's time for learning to love. Now that you have decided which printer you think you want, but before you shell out your hard-earned cash, spend a couple of hours on YouTube and view some videos on how to unbox and set it up. You will save time and maybe some frustration. Just enter the name of the model you are considering and words like unbox or set up. Other words like problems and troubleshooting can be illuminating as well. No one is perfect, and neither are any 3D printers. It takes time to learn the little things that make a relationship successful and happy, and I call this phase learning to love. For starters, my 3D printer came with some assembly required. The instructions were a series of illustrated steps without any narrative. Think IKEA. But the requisite tools were included, and assembly took less than an hour. In retrospect, I was glad it was not plug and play, because I learned a bit about the internals. The unit could be connected directly to a PC as a USB printer, but I chose the option to drive the printer from the SD card that came with the printer. The SD card even came with some demonstration files on it. I leveled the print bed and inserted the SD card. I loaded some PLA filament into the extruder and turned the machine on. The display sprang to life. The actions are controlled by turning a knob and pushing the knob when the desired action is highlighted. I selected a model to print, and things started happening. I was printing an object. Success! I admit it. I had grandchildren with me that weekend, and I spent the next 2 days downloading and printing Pokemon characters and bathtub boats for their amusement. But it got me going, and I suggest you start by doing the same thing. A word to the wise. You will go through more than one extruder nozzle, so buy some spares. I bought a box of 2 dozen from Amazon for my Ender 3 Pro, and I'm glad I did. I also bought extra brass extruder wheels. These parts are considered expendables. While you are at it, buy a kilogram roll of white 1.75 millimeter PLA filament. Not much of this comes with the printer. I like filament from One from Amazon. Tool-wise, if you need to change a nozzle, a 1/4 inch ratchet wrench with a 6 millimeter socket will come in handy. If you are using your own printer, you will need to learn about a step called slicing. Slicing is a software step which takes the STL file created by a CAD program and transforms its contents into a G-code file containing instructions to tell the printer where to move the axes and how much filament to extrude. A version of the Cura slicing program came with my printer, but it was at least 3 major releases behind the version that was available for free on the web. So I quickly downloaded the current release and set aside the one from the printer vendor. Slicer software can work with many different printers, and after installation, it does require you to tell it what printer you are using. Now, I just import a model into the slicer, but I may want to alter its size. To do so in Cura, I click on the object and then on the button on the left that looks like 2 hourglasses in different sizes. When I do so, the slicer displays the width, depth, and height of the object, and I can enter new values in millimeters or percentage. If the uniform scaling box is checked, a change of size in one dimension will also alter the others proportionally, or if unchecked, the size will be altered in only one dimension. After that, it is little more than clicking on the slice button and saving the G-code file to your SD card or hard disk for eventual printing. There are options, the most common being selection of the quality you want, setting the temperature specifications of your filament, and what type of build plate adhesion you want. If the object has legs, such as found on a dumpster or table, you may want a raft to make sure the object does not separate from the bed. But if the surface of the object is flat, like the back of a wall, then no special adhesion may be required. There are about 6 other settings in the slicer that might be useful to me once I learn how to use them. Leveling the bed must be done during the assembly process and regularly thereafter. The replacement springs helped hold the bed in place, but I still level the bed after about every 10 hours or so of printing. It takes less than 2 minutes to do so and is well worth the effort. If prints don't want to adhere to the bed, leveling is one of the several things I check. Another is scrubbing down the bed with isopropyl alcohol, 91%, after each large print. And I do mean scrub, not wipe down. Oils on the magnetic cover will get you every time, and the result will be a spaghetti monster. I generally watch the extruder deposit the first layer before walking away. If the first layer is solid, you have about a 90% chance that everything above it will be stable. Inserting filament into the extruder motor mechanism is easier once you learn to cut the end square and straighten about 2 inches of filament before trying to load it. Since the filament comes on a roll, it has a certain curve to it, and if not straightened, makes it almost impossible to get it into the Bowden tube. Sometimes it helps to rotate the filament a bit. If it takes me more than 3 tries to get it threaded into the Bowden tube, either I didn't straighten the filament enough, or I am pressing too hard on the mechanism lever. You will learn with experience. And not all filaments are created equal. In the beginning, I wanted as many colors as I could afford, so I bought a multi-pack from Gizmo Dorks and was not as pleased as I had hoped, mainly because the filament tend to get stuck on the spool and break, which of course ruined the print. I have been happy with the smooth-running filament from Everyone, and it tends to be my filament of choice. I bought a 3-pack of metallic filaments, gold, silver, and copper, sold by a company with the strange name of HZST3D, and was pleased with the result. Mica 3D makes some good filament, but it is just a little bit sticky, so I have taken to unrolling several meters of filament from the roll at the beginning of the job, re-rolling it back before printing actually starts, and then repeating this exercise several times during the job, especially if it is a large job. All of the above are sold through Amazon. Finally, I like the deep colors from Coax, made in the USA, but you will have to search for them on the web, as Amazon does not carry their brand. I have been successful spray painting my 3D prints and painting with brush-on acrylics. I have had no trouble with gluing 3D parts to each other or to styrene with either CA or bonding. I learned the hard way that PLA filament rolls should be stored in airtight containers, along with desiccant packets. Otherwise, they will absorb water and require drying before they can be used. Before long, it was time to start raising a family of HO parts for my railroad. Again, I went to the libraries and downloaded and printed some detail parts, including cats and dogs, awnings, trash cans, tires, dumpsters, cars, trucks, motorcycles, boats, and small buildings, with varying success. Success seems to be related to how much I needed to alter the scale. If an object needs to be reduced by more than 50%, I am asking for trouble. The components that are small to begin with, like cable wires, wheel spokes, and window frames, are often too fragile to survive. My best luck seemed to be from Thingiverse when I included HO scale in the search criteria. Things like dumpsters, which I expected would scale well down to even 10%, often look fragile when printed. But there are so many good models out there that you will probably want to push the envelope anyway. Just be advised. I did want to share a few models I downloaded and printed from Thingiverse which turned out well. Among the first I printed were houses, the Ionia, the Dayton, and the HO scale tenant's house, and I liked the results. I also liked the miner's cottage from Badger Breath. For accessories, I liked HO scale travel trailers, HO scale office trailer, HO scale picnic table, gazebo, and containers, HO stackable version 4, and many more. There are some nice standalone structures, such as gas stations, diners, a theater, and brick commercial buildings. Just open Thingiverse and search for HO scale. I was disappointed that I found so few HO vehicles that would print without supports. Designers should create vehicles with separate tires and wheels to allow the body to print without supports. I print most of these in white to minimize filament changes, and gluing pieces painted with spray paint has not been a problem. It's no secret that I was successful in 3D printing some of my own designs, so may I share a few? My first original creation was a building interior I used in my amazing Arduino animations clinic. This interior is designed to separate rooms and floors, allowing each room to be lit independently. The trickiest part of any printing is to make sure the object sticks to the build plate, and for best results, I designed the object such that the largest flat surface lays directly on the build plate. In this case, the back wall of the interior is on the plate, with the walls, floors, and ceiling growing up from it. I learned that, at least in Tinkercad, it is not enough for walls and floors to meet. They must actually intersect. Consider a building where there is 35 millimeters between the top of one floor and the bottom of the next floor. For our purposes, assume that the floors are 2 millimeters thick. How tall should the walls be? 35 millimeters? Such touching joints did not work for me, but 39 millimeter walls that actually penetrated the floors above and below, did. This is actually easier to do than it sounds, because Tinkercad has an align function that makes it easy. Once in place, I group all the walls and floors to make a single unit, then print. I use 5-volt LEDs on a roll to light my rooms, and control them with an Arduino microprocessor. I decorated the walls with images I downloaded from the internet and attached with rubber cement. Hot tubs were not really a thing back in my transition era layout, but I always wanted one in real life, so I decided to design one. It's really nothing more than a bunch of cylindrical solids and holes. My wife insisted, for safety's sake, the tub should have steps and a handrail. Brown paint decorated the outside of the tub, white the inside, add unpainted seated figures covered with swimsuits and COVID-19 masks, and voila! We had a socially distanced soaking experience. I used clear silicone caulk and a drop of clear blue paint for the water, swirling a toothpick to simulate waves and bubbles. Next, I decided my layout room needed a herald of my layout, the Baden, Vogt, and De Smet, the 3 elementary schools I attended as a child. But what was I going to use for typography? My official logo uses Windows Algerian typeface, and Tinkercad is limited to 3 pretty nondescript fonts. Time for trick number 1, a little complicated but very effective. I used PowerPoint's text box tool and entered the name of my railroad, Baden, Vogt, and De Smet, on 3 lines and indented. I changed the font to Algerian and increased the font size to 100 points, about enough to occupy the entire page. I clicked on File, then Save As, and down at the bottom, where it says Save As Type, I selected a PDF file type and clicked the Save button. Since that was the only thing in this particular presentation, the name of the railroad was all that was saved. But if you desire, you could use the Options button to save just the current selection or a specific page. But so what? Tinkercad and Cura don't know how to import a PDF file. True, but the anyconv.com website does know how to convert PDF files into STL files, which both Tinkercad and Cura can import. So I opened anyconv.com, navigated to the PDF file which contained my Algerian text, told anyconv that I wanted it converted to STL format, and hit the Convert button. Once converted, I hit the Download button, and immediately my PDF file was converted into an STL object and placed in my Downloads folder, which can then be imported into Tinkercad. In Tinkercad, I imported the new STL incarnation of my railroad name. The text is tiny, so I upped the scale factor from 100 to 10,000 and started the import. Once the import was completed, I reduced the height of my text to 2 millimeters. And lifted the text to 2 millimeters off the build plate. I rotated the text 45 degrees and moved it into my desired position. My extruder can extrude only one color filament at a time, but I can't export just certain parts into printable objects for the slicer. So I first exported the purple field into one file, and next the gold rim and text into another. My plan was to print the purple file, and when it completes, I'll change the filament to gold and print the second one on top. But things are about to get tricky. It is a fact that if an object is suspended in air, like my gold rim and lettering, by default, the Cura slicer will automatically drop it back down to the build plate, ignoring the fact that we wanted to suspend it above the first layer. This means that the second layer will not float on top of the first, unless you know a trick. There is a special G-code command, M206, which we can insert into the beginning of any print job, which will offset the height of all subsequent extrusion commands. How do we make this happen? We do so by opening Cura's Preferences tab, then on Configure Cura, then on Printers and Machine Settings. In the lower left is a box labeled Start G-code. I scroll down to the very bottom and added a new line, M206 space Z-1.98, to add an offset of 1.98 millimeters to all subsequent extruder movements in the Z-axis, thus raising them above the back of the logo. Why 1.98? Well, the background is 2.00 millimeters tall, and I wanted the gold to be ever so slightly attached to the background, so I made the offset just a bit shorter than the underlying field, and it worked. If I had made the background 1.50 millimeters thick, I would have made the offset 1.48, and so forth. I also added a line M206 Z-0.00 at the end of the end G-code block to reset the Z-axis offset at the end of each print job. After slicing the gold rim and letters, go back into the Start G-code box and place a semicolon in front of the M206 line, which will turn it into a comment, and then all subsequent slices will drop back to the build plate. I like to keep the line there in case I again want to raise a layer, but if I don't turn it off, all subsequent designs will be elevated and turn into spaghetti monsters. With a semicolon placed at the start of the M206 line in the Start G-code section, I printed the first layer in purple. I then removed the semicolon to elevate the gold layer and printed it, and it worked. I then replaced the semicolon to turn off the offset elevation, and I was ready to print another non-elevated object. Once I got the hang of it, I made some additional heralds for friends. Next, I used a similar overlay technique to create a billboard for radio station KDMR, which delivers news, farm reports, and sports to the surrounding area. Yes, I could have printed the call letters in station format separately and then glued them to its backer board, but once I learned the overlay technique, I kind of like using it. The billboard design and support legs are available on Tinkercad under my name. But don't think that just because I have shown you a few successful 3D prints, that everything about 3D printing is sunshine and roses. Like any relationship, there will be times when you are disappointed and disillusioned. Filament will break, the nozzle will clog, and the Bowden tube will get sticky and need replacement. You will need to learn how to recover. After totally clogging my printer's hot end, I learned how to clean it by visiting YouTube and searching for Bowden Tube Gap by Tom Tullis from the Tomb of 3D Printed Horrors. I ended up removing the extruder fan, scraping solidified filament from the hot end, removing the nozzle, reaming the hot end with the Bowden tube, and putting it all back together. I was sure glad I bought extra 0.4 millimeter nozzles because the old one was pretty shot. Despite the strange name of his website, Tom Tullis has a lot of useful operational hints, so you might want to browse what he has. So what have I done lately? I have found quite a few more models in libraries that have contributed to my layout. I found this radio antenna and Quonset hut design on Thingiverse and added a blinking LED to the top using an Arduino microprocessor. Here is Green's Cafe, also from Thingiverse. The sign over the door is a custom decal of mine. I modified Green's a bit in Tinkercad to create Bubba's Beer, Brats, Bait, and Bullets, and I designed the fence myself in PowerPoint, a technique I describe in my clinic on 2.5D CAD. I found a designer with whom I collaborated to create the bedroom units and the office of the Coral Court Motel in St. Louis, an infamous no-tell motel on Route 66 back in the day. Other downloads include this service station and bus station. Here we have a bakery. I've printed throttle holders and stretched one into a holder for 3x5 cards. On my own, I've created windows and a rustic door using the layered trick. As my skills improved, I learned how to design board and batten siding, clapboard siding, and corrugated roofing, which led to the creation of a tractor shed. Highway overpass decorations, pedestrian dividers, picnic tables, and a picnic pavilion as well. I now make baffles for speakers for sound decoders in DCC locomotives. I make supports for signs. I even created a replacement part for an old Atlas locomotive when I dropped a small plastic pin on the floor and could not find it. My mind has evolved to the point that if I get an idea, I now ask myself, how can I create that on my 3D printer? I am getting pretty good at consistent success with my Ender 3 Pro. Keeping my magnetic bed scrubbed down with 91% isopropyl alcohol made a big difference in object adhesion. I still level the bed regularly, but I am down to every other day. I don't crash the nozzle into the underlying object anymore when doing layered prints. I store my filament in plastic bags with desiccant. I am having a lot of fun. If you would like to have a handout containing the major points of this clinic, please visit my website at http://dackm.github.io or email me at acmans@charter.net. I expect that in 7 to 10 years, 3D printers will be as ubiquitous in the home as personal computers are today. Right now, the path is not easy. The road is expensive, but the journey is its own reward. If you like what you have seen and can accept and learn from the bumps along the journey, I hope you enjoy the rewards. Thanks for joining me along the road.